let's take a look at 33. All right, so 33 said we want to find the GCF. All right, so we want to find the GCF of 8, 16, it's running out. 8, 16, and 20. Is that right, Michaela? Okay. So to find the GCF, you have to do prime factorization. So I'm going to do the prime factorization of all three of these. Well, 8 is 2 times 4. 2 is prime. 4 is 2 times 2. So there is 8 prime factorization. 16 is 2 times 8. 2 is prime. 8 is 2 times 4. 2 is prime. 4 is 2 times 2. So I like to, as I've said to you guys, I like to circle my prime numbers. So when I'm done, I know that I found what I needed. One second. All right, the next one is 20. So I have 2 times 10. I have 2 times 5. Again, it doesn't matter what two numbers you start with. 20, I could have started with 4 and 5. What's up, Jack? Not unless it's an emergency. I'm in the middle of doing this. If it's an emergency, you can, but you need to stay here if you can wait. All right, so questions on the prime factorization part of this. Okay, so to find GCF, I'm going to go ahead and list these. So 8 is 2 times 2 times 2. 16 is 2 times 2 times 2 times 2, 1, 2, 3, 4. And then 20 is 2 times 2 times 5. All right, once I have the list of the prime factors for each, what do I do now to find my GCF? What do I do now, Frankie? Excellent. So they have this set of 2's in common, correct? So they have that 2 in common. They have another set of 2's in common, so I have 2 times 2, and I think that's it. So they have, so your GCF prime factors are the ones they have in common. I'm not multiplying 2 times 2 times 2 times 2 times 2 times 2. They each have 2 2's that I have to multiply together. So my GCF is 4. The mistake that I'm seeing is that many of you, some of you are multiplying all of them that we have circled, not recognizing that, oh, they just have 2 2's in each list in common, and then multiply those 2 2's. Michaela, does that help you? Awesome. What else can I do for you guys other than 29 and 44? Angela? 22? All right. So 22 said I have 3 times y squared and 24y to the third. And again, we are looking to use prime factorization to find the GCF. All right, so 3 is prime. So there's nothing I need to do for 3. You don't even need to do the prime factorization of 3. It's just 3 times 1. There's not anything you really need to do. So we're going to leave that alone. All right, we have 24. That's going to be 2 times 12. 2 is prime. 12 is 2 times 6. 2 is prime. 6 is 2 times 3. Both of those are prime. All right, so now I'm going to list this. I have 3y squared is equal to 3 times y times y. I do have to see this list written out. All right, 24y to the third is going to be 2 times 2 times 2 times 3 times y times y times y. So Angela, are you cool so far? Okay. From here, we're just going to circle what factors they have in common. Well, they have this 3 in common. So my GCF is going to start with just a 3. Not 3 times 3. They both simply have a 3 in their list. Then they both simply have 2 y's in their list. So there's my y times my y. So my GCF is 3y squared. Angela, does that help you? Okay. Let's take a look at number 29. As I said earlier in class as I was walking around, it's really important that when you're reading story problems, you recognize what process is it that I need to use to solve this. All right, is it something that I need to come up with a game plan for? Do I have a part equal to my whole? Is it something that I can use my rows and my columns? Is it something I can use GCF for? All right, so when we read this, 29 says a math teacher and a science teacher combine their first period of classes. We have math class, and they have 24 students. And we have science, and science has 16 students. Now, here's the thing. Because there are two different total amounts, all right, we don't have a situation of where we have one amount that we're dealing with. When we have to do the rows and columns, all right, they were asking for what are all the possible combinations of how we can arrange the students if we want to have them in rows with the same number of students in each row. That's when we do our rows and columns and we use our factors. That's not what this is asking for. I have two different groups, and then it says they need to divide them into groups of same size. So I'm dividing these into the same size number of groups. All right. So it says each group must have the same number of math students. Teacher needs to divide the students into groups. Each group must have the same number of math students. Find the greatest number of possible groups. We are dividing into groups. That's the first thing. And we want to know the greatest number of groups. That right there indicates that we have GCF. All right, and we want the same number of each type in each group. This indicates that we have to do GCF. All right, so I'm going to go ahead and do my prime factorization. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. 16 is 4 times 4. And both of them break into 2 times 2. So now we have 16, which is 2 times 2 times 2 times 2. 24 is 2 times 2 times 2 times 3. So now I've listed them. And now I'm going to circle the ones they have in common. So my GCF, they have 1, 2 in common. They have another 2 in common. They have another 2 in common. And those are the only ones they have in common. So I have 2 times 2 is 4. And 4 times 2 is 8. So what that means is, and remember we need to know what the GCF means. That means that we can divide the classes into 8 groups. Jack, go if you need to. Go if you need to. Questions on 29? Okay, let's take a look at 44. Let's take a look at number 44. Somebody tell me what 44 says. What's 44 asking for? What information do they give me and what are they asking for? Michaela? Okay. So we want each row, same number of chairs. What else what are they asking for us to find? Okay, so it says what is the greatest number of chairs possible in each row? So we want to find the greatest number of chairs possible in each row. All right, these two together indicate GCF. We need to have the same number of chairs in each row. That statement is very similar to the statement where we had, what are all the possible combinations? How many of you guys recognize that? Okay. But the difference here is well, so that's the same statement. What's different though? What's different in this problem than one where we would have had what are all the possible combinations and we would do rows and columns? What's different in this problem? Come on, talk to someone sitting by you. What is different in this problem than ones where we would have to do rows and columns? What's different? Come on, talk to someone by you. Turn around if you want to, sweetheart. You're more than welcome to talk to them. What's different in this story problem than in the ones where we have to do rows and columns? If you're not sure, go back in your notes. Because you have to know the difference between them. What's different? So this one says the first section is going to have 126 chairs. The second section is going to have 588 chairs. We want to divide all those chairs up so we have the same number of chairs in each row. What is the greatest number of chairs possible that we can put in each row? How is this different than the ones where we have to do the number of rows and the number of chairs in a row? What is different in the wording? What is different in what they're asking us for? What is different in what they've given us? What's different? Christiana? At least, well, we could do at least how many do we want in there? Okay. What else? Romano? It says find the greatest number of chairs possible. How many of you guys noticed that? Okay, that should tell you we've got GCF. If it was rows and columns, what would they be asking us for? If it was a part that we had to do rows and columns, what would they be asking us for? Maya? Mia? Find all the possible arrangements. Absolutely. What else is different in the givens that they've given us between this one and the other one? Pierre? There's two numbers. How many of you guys notice that there are two of them? All right. In ones where we have to find all the possible arrangements, they probably would only give us the 588. We have 588 chairs. We need to put them into rows where we have the same number of chairs in each row. What are all the possible combinations that we could have in arrangements? Okay, so understand the difference between those. Okay, now that we know we have GCF, I have to do my prime factorization. Somebody tell me what I'm going to start with for the prime factorization of 126. Aaron, go ahead. 263, okay. 7 and 9. All right. Excellent. Nice. Somebody do 588 for me. Come on. I know it's harder, but you do know that it is divisible by 2. All right. Kira, go ahead. 294. Awesome. Say that again. What is this? I can't hear you. Thank you. 147. Sorry. And then 147, is that prime? What is that? Excellent. Those bigger numbers can be harder. That's when we use our divisibility rules. All right. Okay, so now I have 126, which is 2 times 3 times 3 times 7. And then 588 is 2 times 2 times 3 times 7 times 7. And now we just need to list these. So they have a 2 in common. So here's my GCF. They have a 2 times, well, they have a 3 in common, times they have a 7 in common. So 2 times 3 is 6. So that's 42. All right, what does that mean? So if our GCF is 42, what does that 42 mean? Mateo? Yeah, the greatest number of chairs per row is going to be 32. So the greatest number of chairs in each row is 42, or something like that. Always go back to what they're asking you for. You know, one of the things that it's important is I think you guys have done a really good job of writing down your givens, but the question is, did you write down what you were looking for? Because if you write down what you're looking for, writing this sentence would be really easy. Because you've already written up here, you can always go back and be like, okay, what was I looking for? Oh, that's number of chairs. So my answer is the greatest number of chairs. Are there any other questions from the homework? Okay, put this away, get your notes out. We're going to practice a couple more of these story problems, because you never know when you have a homework quiz. Never know when you're going to have a homework quiz. You can show me in study hall today. If you have a study hall, that'd be awesome. Okay, today is the 6th. I hope you all heard my hint. Just saying. I hope you've heard my hint. Okay. So we're going to practice using greatest common factor. All right, I'm going to show you a story problem. You are going to need this data. There's a table of data here. It's really important that you guys know how to read a table of data. I don't necessarily want you to write down, like draw the table of data, but you need to write down the information that you get from the table of data. Do you guys understand? Okay. There are 2 things it's asking you for. We're going to focus on the first one, and then we'll do the second one as well. So make sure you read the whole thing, write down what you are looking to find, write down the information they've given you so you can find what you need to find. Does that make sense? Again, you don't need to draw this table, but you need to know the information from this table, so write the information down. Go ahead. Pay attention to reading the table. When you're reading it, take a look at what the information in the flowers, those number of flowers, know what the increments are, so you know how many flowers there are. if I read this table, how many daisies, what's the total number of daisies that we have based on that table? What's the total number of daisies we have there? Layla? How many of you guys agree it's 58? What are we counting by? What are each one of those little lines? So pay attention to what we have here. This right here, this increment right here is 14. This increment's 28. This increment's 42. So tell me, what are we counting by? You have to figure that out. If this is 14, and there's one in between there, and these are all equal, what is each of these increments? What are we counting by? Here? This is 14. What is this? We're counting by sevens. How many of you guys notice we're counting by sevens? You have to figure that out first. Okay, since this right here is 14, and there's another one in between here, we're counting by sevens. So if I look at my daisies, what is this number? If this right here is 56, what is that? If I'm counting by sevens. Addison? 63. Right? So 56 plus 7 is 63. So I have 63 daisies. How many lilies do I have? How many lilies do I have? Aaron? We have 56 lilies. How many irises do I have? Frankie? We have 42. Michaela, how many freesias do I have? We have 21. That is the most important part of starting this, is making sense of that graph. Pay attention to what you're counting by. That can be confusing. Don't just whip through that graph. Read it, look at the increments, look at what you're counting by, figure out what the information is. Now that we have that, finish it. So the first thing you're finding is the greatest number of identical bouquets. So they're having identical, meaning the same number of daisies in each, the same number of lilies in each. The second part is how many of each type of flower are in each bouquet. We got to figure out that too. So let's do the greatest number of bouquets first, and then we'll figure out that second part. All right, somebody tell me, what did you get for the prime factorization? What's your final prime factorization for 21? What's your final prime factorization of 21? Dominic, what would it be? Listen to me. You have to find the prime factorization of each of these numbers. To find the greatest common factor, don't we need to do the prime factorization of these? All right, so right now, the data that I have, these are my totals. I have 63 daisies, I have 56 lilies, I have 42 irises, and I have 21 freesias. I'm looking to find the greatest number of bouquets, which means I need to find the GCF. What is your final prime factors for 21 once you've done the GCF? Aaron? 3 times 7. How many of you guys got 3 times 7 for 21? All right, how about 42? What's your final prime factorization for 42? Angela? So 2 times 3 times 7, right? Okay. How about for 56? What's the final prime factorization for 56? Alex? Excellent. 2 times 2 times 2 times 7. What's my final prime factorization of 63? Audrey? Excellent. So this is what you guys should have for the prime factorizations once we do our factor trees. All right, this should be our prime factorization. What's the only thing they have in common? Jack? 7. So my GCF is simply 7. What does that 7 mean? What does that 7 mean, Kira? Exactly. We can make 7 identical bouquets. Now, the second part to this said, how many of each type of flower? It said, what will each bouquet contain? Which is how many of each type of flower? How am I going to figure that out? How do I figure out how many of each type of flower? Alex? Excellent. All right, so what we're going to do is we're going to take our daisies. All right, we have 63 daisies. If we divide that by our 7 bouquets, we're going to end up with 9, right? So 9 daisies in each. How about my lilies? What was our total number of lilies? Come on, what was our total number of lilies? Emerson? 56. What's 56 divided by 7, Emerson? So we have 8 lilies in each. All right, how about our irises? Christian? So 42 divided by 7, so how many? 6, excellent. And then our freesias. How many total freesias do we have? Mateo? 21. So how many freesias in each? 3. You guys cool with this? You're going to see this kind of thing again on potentially a homework quiz. Come find me before the end of the day if I haven't found you to give you your worksheets, okay?